So last time we left off, we were multiplying, we did monomials and then multiplying a monomial by a polynomial. And now we're going to multiply together two binomials. So each set of parentheses has two terms on it. So this is in the 5152 notes. It's where we left off last time. So we finished the multiply and simplify down here. Next page should have multiply and binomials. Does everyone have their notes with them from last time? Okay. So there's a special process we use when we multiply two binomials together. Does anyone remember what it's called? Foiling. It actually is a form of distributing. It is a form of distributing, but the kind of special process name for it is foiling. And that's doing multiplying out our first terms, our outer terms, our inner, and our last. And what you're doing is you're actually distributing twice. And if you think about it that way, it'll help you for when you need to multiply together larger polynomials. Because this process is the same even as we make our polynomials bigger and bigger. So when you FOIL, what you do is you start by taking the first term and multiplying it by the first term. And then you take the first term and multiply it by the outer term. So first, outer. But what's really happening there is you're just taking the x from the first set of parentheses and you're distributing it through the second set. That's what the F and the O of FOIL are, is saying take the x and multiply it by the x, and then take the x and multiply it by the 5. And you do not necessarily need to write these steps out. I think at this point most of you can probably do that multiplication for the FOIL steps in your head. Again, I'm just writing out kind of everything that's happening here. So to get the I and the L of FOIL, what you do is you go back to this first polynomial again, and you distribute the -7 through the second set of parentheses. So you take -7, you multiply it by x, and then you take -7 and multiply it by 5. And if you think about it like that, you think about the fact that you're just distributing this first binomial into the second one, that'll help when we get to the next set of problems, which is multiplying a binomial times a trinomial. Same idea will carry over. So what do I get for x times x? X squared. Then I have plus 5x. And again, if you started at this step, that's absolutely okay. Minus 7x minus 35. And then it's always a matter of, do I have like terms that I can combine? Yeah, the 5x and the -7x. Both have an x. Combine them together, so I'm going to have x squared minus 2x minus 35. And again, if you've taken this class before, or as soon as we get into chapter 6, do not try to factor that. If you try to factor that, all you're going to do is get back to the problem. If you don't know what I'm talking about, that's fine. It's good for now. That's it. That's the multiply part of our FOIL. So we're going to do the same thing with B. We have a binomial times a binomial. We're going to FOIL, which is really distributing. So we start by distributing the 4x. Multiply it by every term in that second set of parentheses. So 4x times x. Again, you don't need to write this step. And then 4x times -6. And then we're going to come back and we're going to distribute the -3. So I have -3 times x and -3 times -6. I've got a little bit of cleaning up to do. So 4x times x is 4x squared. 4x times -6. Remember, you can multiply anything together. They don't have to be like. -24x. -3 times x, -3x. And then on my last two terms there, watch your signs. Negative times a negative, +18. And a lot of times we do get like terms. These middle two are like, so we can combine them together. So I'm going to have 4x squared minus 27x plus 18. And where we're going, where we really start 083, is actually a topic you do in 082 as well, is we're just going to reverse this process. So what we're going to do in all of chapter 6 is factoring. And what factoring is I'm going to give you this as the problem, and you're going to work your way back to the parentheses. So just that's where we're going, is the reverse of this process. Now, C and D are problems that you actually see on the placement test if you take the AccuPlacer to see what math you need to go into. They're also commonly missed problems because people forget the rules for these and they just try to distribute the square. But you can't just say, okay, x squared, 3 squared, x squared plus 9, and I'm done. Because there's an addition sign in the middle there. You can't distribute the squares. So for a problem like this, x plus 3 quantity squared, think about what a square means. So what's 5 squared? What do you get if you square 5? 25. And how do you get 25 from 5 squared? Right, so 5 squared, just as a side, 5 squared is 5 times 5, which gives us 25. So when I say x plus 3 squared, the whole quantity squared, a little bit. What this means is x plus 3 times itself. You've got to get that x plus 3 written twice because the squared means multiply it by itself. And only after we write it out, we see, okay, it's a binomial times a binomial. We're going to have to FOIL this one as well. So it doesn't look like a FOIL problem to start, but when you have a binomial squared, just write it twice. That's what the squared means. And then go through and we're going to FOIL this. So we can start with x times x. It's me x squared. X times 3 is 3x. 3 times x is another 3x. And 3 times 3 is a positive 9. Now, if you showed me this work and then you got the wrong answer, I would give you partial credit. If you just wrote x squared plus 9 with no work, then you would get no credit. So it's always in your best interest to show me something. Because what happens sometimes on these problems is people say, oh, 3x and 3x, cancel, cancel. But they don't have opposite signs, so they don't cancel. So if you make that mistake but you have this work, I will give you partial credit because you were on the right track. You just didn't get to the final answer. But we should really end with a trinomial for any of these problems where you're squaring a binomial. So we have x squared plus 6x plus 9. Questions? Dennis? What do you mean simplify? What's the problem? So don't factor the multiplication problems. If you write x plus 3, all you've done is told me what you multiplied out to get there, and then you've gone right back to the problem. So unless it says factor, or it's some process where we know we factor, just multiply or simplify. Don't factor those final answers because you're just going to get back to the original problem. Any other questions? All right, so D is the same thing. You see a binomial squared. Write it twice, but don't just stop there. You've got to actually multiply it out. So 2x minus 6 squared. This means 2x minus 6 times 2x minus 6. Squared means multiply it by itself. Binomial times a binomial. I'm going to go through and FOIL. And if you want to write out every step of FOILing, you're more than welcome to. Again, a lot of this you can probably multiply in your head now. So 2x times 2x is 4x squared. Remember, if you're multiplying two x's together, you get your x squared. 2x times negative 6, negative 12x. Negative 6 times 2x is another negative 12x. When you're squaring a binomial, those middle two terms should always match. And then a positive 36. Combine your like terms. Again, they don't cancel because they have the same sign. So we have 4x squared minus 24x plus 36. So any questions on FOILing? So we're going to use FOILing to check our answers in Chapter 6, a lot of them. So the one other type of multiplying that we'll need to be able to check our answers in Chapter 6 is multiplying a binomial times a trinomial. When we go and factor cubes, they're going to end in this form, 2 and then 3 terms. So it's just like FOILing, except you've got to reach one more term each time. That's why it's helpful to see the FOILing as just distributing. So when you want to multiply a binomial times a trinomial, and this extends to any type of polynomial, start with the first term in your binomial. Distribute it to each term in the other set of parentheses. So if we were FOILing, we would go 1, 2, and then we'd be out of terms. The only difference here is you just got to multiply it by one more number. So we're going to start and take the 7x times the 2x squared. Again, you don't necessarily need to write this step. 7x times the negative x, and then 7x times the negative 1. So you can see here's our trinomial, 2x squared minus x minus 1. And then we're going to go back, and we're going to just take the negative 2 and multiply it 1, 2, 3 times. So we're going to take the negative 2 and multiply it by each term in the second set of parentheses. So negative 2 times 2x squared, negative 2 times negative x, and negative 2 times negative 1. So let's clean this up a little bit. I have 7x times 2x squared. What do I get? What do I have, Tiffany? 14x cubed. So you've got to multiply the coefficients. Your 7 times 2, and all together we have 3 x's, which is x to the third power. 7x times negative x minus 7x squared. 7x times negative 1, negative 7x. Negative 2 times 2x squared, negative 4x squared. Negative 2 times negative x, positive 2x, and then negative 2 times negative 1, positive 2. And again, if you went right to that line right there because you're multiplying in your head, that's perfectly acceptable. And then it's a matter of finding our like terms. Since we have one variable, it's nice to write them in descending order. They don't have to be. So I have no other terms that have an x cubed, so that'll go all by itself. I can combine my two terms that have the x squareds on them. Negative 11x squared. I can combine the two terms that have the x. Negative 5x. And then my constant on the end. Questions? All right, go ahead and try B. See if you can get B. See if you can get all of those exponents to line up, all those coefficients, all those like terms gathered. So it's 3x squared plus 5 times x squared minus 6x minus 1. if we can agree on an answer. So can someone tell me what the, I don't know, I will put the work up as well, but can someone tell me what their first term of their answer was? Your name again? Devin. Okay. I think 3x to the 4th, okay? Someone who's got the second term. Ayana? Right? Yep. Negative 18x to the 3rd. Muna, do you have the next one? 2x squared. Your last name is Sacco. Robert. Negative 30x. Last term, Adam. Minus 5. Anybody disagree with any of those? All right, let's see where they came from. So again, think about this like, I call it the superfoil, because it's foiling, but you've just got one more term that you've got to reach on the end. And again, you can extend this idea to any number of terms. And if you don't want to write this step right here, that's absolutely okay. But we're just going to take the 3x squared and multiply it by each term in the trinomial. Then we're going to come back and take the 5 and multiply it by each term. So there's our 3x to the 4th minus 18x to the 3rd minus 3x squared plus 5x squared minus 30x minus 5. And then there's not a whole lot to combine here for like terms. The only ones that we have like are the x squareds there. Now when I take the negative 3 plus 5, that gives me the 2. Everything else just comes down. Questions? You will not be factoring something that looks like this. I'm not going to give you this problem and say, where did that come from, and expect you to go back. Nothing will ever be that ugly. So any questions on our multiplying, simplifying? They're really the foundations for what we're going to be doing. So that's the end of our 081 review topics. Where this course actually starts is 6.1. So who remembered to print their guided notes for today? All right, so a few of you maybe not want to raise your hand. So the first day, I still cut you a little slack. I have copies of 6.1. Who needs a copy? So this is the last day. I will be bringing them. If you want them from here on out, slides on the board again. If you haven't already, go on the blackboard and get these for yourself. If you're really having trouble getting access to a printer, just let me know and I can help you out. Generally speaking, this is the last time I will have them for you. We'll use those. Hold on. No, each unit lasts like 3 minutes. So you won't be doing it a lot. But if you want to. Everybody have a copy? Okay, so we're gonna, chapter 6 is all on factoring. This is the test where you want to do really well because it is the easiest test. It's our first test. It's the easiest one. So what is factoring? A lot of your directions are going to simply say factoring, and we're going to spend the next couple weeks learning all kinds of different types of factoring. But what does that even mean? Well, this is a definition. I think I got it from the old book for this course. It says to factor a number or expression means to rewrite it with numbers or expressions that can be multiplied together to get the original number or expressions. I don't think that really, for most people, describes any better what factoring is. A lot of numbers and expressions in there. So what it means, this is how I like to think about factoring. Factoring is like Jeopardy. The problem you're told to factor is the answer to a multiplication problem. What you need to do, your job, is to show me the most broken down multiplication problem that, if you worked it out, would give me that polynomial. So, like I said before, I'm going to now give you something that looks like x squared minus 2x minus 35. It's the answer to a multiplication problem. Your job is to tell me what the problem was. That's what factoring is. It's the reverse process of multiplying. So you get the polynomial, you work your way back to a multiplication problem. But there's a lot of different ways that we're going to do this. So the first thing we're going to learn about is factoring a greatest common factor. And there's a little reminder here. It says when dividing like bases, subtract their exponents. So this is actually a topic again from 082. But it's something like if I have x to the 5th and I divide it by x to the 3rd. You get x squared. So you just take 5 and subtract 3. And for our factoring purposes here, we will never have a negative exponent. We'll see those later in something separate, but factoring, you shouldn't ever be dealing with negative exponents. So if I had, let's say, x to the 6, and I want to divide it by x squared, I'm going to have x to what power? Robert? 4. So you subtract. What's happening here is you're really taking 6 x's over 2 x's and canceling out 2 of them. That's what's happening when you subtract the exponents. That's how we get back down to x to the 4th. And the most common one we're going to see in all of these problems is x squared divided by x. What's the exponent on the x in the denominator? 1. So if I take the exponents and subtract them, 2 minus 1 gives me x to the 1st, which is the same as just x. So when we're going to see the most. So to factor out a greatest common factor, the first thing we're going to need to do is we're going to need to find the greatest common factor. And what that is it's the term that evenly divides all of the terms in our polynomial. So when I'm looking at something like this, there's 2 things I'm looking for to build my greatest common factor. First, I'm trying to find the largest number, if any, other than 1, that evenly divides every coefficient. It's got to be everyone. Second thing I'm going to look for is, do all of my terms have a variable in common? If they all have the same variable, I'm going to be able to pull that out as part of my greatest common factor. But when I'm looking at variables, I'm always looking for the fewest. So if they all have x's, I've got to say, okay, I can take out x's, who's got the fewest? Because if I have a term that has x squared, there's no way I'm going to be able to pull x cubed out of there. There's just not enough x's there. So we're always looking for variables for the fewest. And then after we find our greatest common factor, we're writing a multiplication problem. It's going to be multiplied by something. To find that something that's left, just divide it out of every term. It should divide evenly. If it doesn't, it's not common. So I resort to word art here to try to get this point across. You start every single factoring problem by looking for a greatest common factor. Not only will it give you a complete answer, it will also, in some cases, make your life a whole lot easier. So you want to start every single factoring problem with a greatest common factor. So the directions on your homework say to factor using a greatest common factor. In general, these problems are just going to say factor. And you're going to have to figure out which technique, and we'll talk about that as we go through, which technique to use. Every problem starts by looking for a greatest common factor. So the first example here, I have 9b squared plus 4b. First thing to do, look at the coefficients and see, do I have any number that will evenly divide both 9 and 4? No. Well, there is one, which is the number 1. The number 1 is always the greatest common factor. We don't usually care. Sometimes we care, but in this case, we're going to ignore the fact that 1 works. It's not going to help us. Do I have any variables in common? B. They both have B, which means I can factor that out. Now, to see how many B's I can take out, I find which term has the fewest. So that would be the second term here. It's just 1B, which means that's all I can take out. I'm never going to be able to take out more than that from the second term. So for the entire problem, my GCF is B. It's what they have in common. But I'm not just asked to identify the GCF, I'm asked to factor. And whenever you see factor, you're setting up a multiplication problem. So it's going to be B times something, that when I work that out, I get back to the original problem. And the way to find what goes in those parentheses is just to take the original and divide each term by your GCF. So I'm first going to take 9b squared and divide it by b. Again, this is, I said, the one you see the most. That b squared divided by b gives me 9b. And then how about 4b divided by b? 4. Those b's will cancel. So this is the complete answer. The answer to a factoring problem should be multiplication. This says b times 9b plus 4. And to check your answers, you can always check factoring problems. You can work back out the multiplication. Make sure you get the original. So if you wanted to check it, so in the box is your answer, but to check it, all you do is multiply it back out and make sure this is your original problem. And that will be the check for any type of factoring. So for B, I now have a polynomial. I want to see, can I factor out a greatest common factor? That's where we always start factoring problems. So there's two things that could possibly go into a greatest common factor. There's the numerical part and then the variables. You might have one, you might have both, you might have neither. So starting with my coefficients, 20, -4, and 12. Is there any number that evenly divides all three of those? If there's more than one, what's the largest? 4. So if you say 2, 2 is a common factor, not the greatest. We're always trying to take out as much as possible here. So we're going to start my greatest common factor with 4. So that's looking at our numbers. Now we're going to look at our variables and see, does the whole thing, each term, have any variable in common? Why? They all have y's. So now I've got to see how many y's I can take out. 2. So they all have y's. I see who's got the fewest, and that's the last term, y squared. That's the most y's I'm going to be able to take out. If I try for any more, I'm not going to be able to get them successfully from that last term. And then to finish setting up our multiplication problem, it's fine if you can see what's left, but what we're really doing, reversing multiplication, we're going to divide 4y squared from each of those terms. So I start with 20y to the 4th divided by 4y squared, 5y squared, -4y cubed divided by 4y squared, minus y. And if you put minus 1y, that's okay for your 4 divided by 4. Generally, if we have a coefficient of 1, we leave it off, but I'm not too picky there. And then 12y squared divided by 4y squared. The y squareds are going to cancel. It's going to be a positive 3. Now, for us, for now, that's all we can do. Generally speaking, when you're factoring, you would then try to factor what's in the parentheses by another method. We don't have that yet, but just looking down the road, GCF is always where you start, but it's not necessarily an ending point. For us, that's all there is. But usually you then look at what's left in the parentheses and try another method. Any questions so far? All right, next problem, 6a minus 7b squared. Looking for the greatest common factor. So what number evenly divides both 6 and 7? Again, there is something. 1. Okay, that might not necessarily help us. Again, sometimes it does. Do we have any variables in common? No. So there's a couple of different ways you could write this answer. Any of them that would be acceptable. If this were just a standalone factor problem, you could either write, that's a really bad N, let's see, not factorable. The answer you're going to see in the back of your book is they're just going to say that this polynomial is prime. Can't factor it. Or the other option, which we'll use in the middle of some other factoring problems, is that 1 is a greatest common factor for anything. If there's no other, sorry, I should say a common factor. If there's no other greatest common factor, 1 always works. Again, in this problem, it doesn't really get us anything. But in future problems, we're going to need to use the fact that 1 is a common factor to any polynomial to factor them further. So you don't need to write all of these, just one of those 3 choices. Not factorable, prime is the short answer, or 1 times our polynomial there. And then finally D, 8x squared minus 2x plus 16. Looking for a greatest common factor. What's my greatest common factor in that trinomial? 2. Can't take out any variables. How many of my terms have an x with them? 2. How many terms are in my problem? 3. If those numbers don't match, can't take it out. So when I'm looking at a polynomial to be common, it's got to be to all of them. I could have a 20-term long polynomial. If x only occurred in the first 19, can't take it out. Common to all of them. So here I have just the numerical GCF. So it could be just the number. It could be just the variable. Could be both. Could be neither. So if I factor out a 2, I'm just going to divide 2 from each of these terms. So I'm going to have 4x squared minus 1x, which is the same as just minus x plus 8. And then if this were part of a problem, once we have more factoring methods, the next step would be to look at this 4x squared minus x plus 8 and try to factor it. But for now, that's all we have. So there should always be, for these GCFs, 2 parts to your answer. The GCF and then the parentheses that has what you multiply it by to get back to the original polynomial. Questions? Now the directions on the next set are a little bit different, and this is going more into just an idea that we're going to use. It says factor completely, but on your homework the directions are factor each polynomial using a negative greatest common factor. And this is a really important point. When would you use a negative greatest common factor instead of a positive one? So in all of these, we chose a GCF that was positive. But down here, it wants us to choose a GCF that's negative. Is there anything, I guess I tell you, generally a negative GCF is factored out if the first term of the polynomial is negative. So notice that this starts with a negative, this starts with a negative. That's when you would use a negative GCF, just in practice, if you're in the middle of a problem, if your polynomial starts with a negative. So for A, I have negative 5b plus 5. So what's my GCF if I'm going for a negative of the greatest common factor? Negative 5. So the greatest common factor to 5b and 5 is 5. Because the polynomial starts with a negative, we're going to factor out a negative 5. And these require just a little bit more care than the positive GCFs, because factoring out a negative number changes everything. It's going to change all of the signs. So if I factor a negative 5 from negative 5b, I divide them, I get positive 1b, or just a positive b. And if I factor a negative 5 from a positive 5, again, I'm dividing them. It switches the sign to be negative now, negative 1. So just a little bit more care goes into factoring out negative GCFs, because taking that negative out switches everybody's sign. So for B, we're going to look for a greatest common factor the same way we did in all of our other problems, but because the polynomial starts with a negative coefficient, we're going to factor out that GCF as a negative. So first, largest number, if any other than 1, it will divide 8, 6, and 18. 2. So we're going to start with a negative 2. And then, can I take out any variables? This time I can take that x out because it's in every single term. So I'm going to take out negative 2x using extra care when I divide to watch my signs. And the reason we use a negative GCF is simply to switch the sign on the first term is now positive 4x squared. Then I'm looking at negative 3x and a positive 9. And again, the reason we really do that is when I go to try in the future to factor this 4x squared minus 3x plus 9, really want that to start with a positive number. Questions? Robert.
You just divide -1 at the end instead of like switching it.
So start with a 2x and then factor again a -1?
No, I mean like, alright, so you solve, or you don't solve, you do whatever it's called, you factor. And then afterwards, instead of like just doing -2 in the beginning, you just multiply by -1. So it switches the signs.
You can't multiply because it's an expression. You've really got to factor it out. So yes, you could get there by doing the -1 kind of second, but you're not multiplying. You're still actually technically factoring.
Well, yeah. Okay,
yep. You can always factor in 2 steps. So this idea of a GCF doesn't necessarily just need to apply to monomials. If our polynomial has a set of parentheses with a binomial in it in common, it's still considered a common factor. So if I look at this, 2r plus 1 times x and 2r plus 1 times y, what do these two terms have in common? 2r plus 1, which means I can still factor it out. Doesn't have to just be a monomial. So what do they have in common? They both have, there's only 2 terms here. What they have in common is 2r plus 1. So if we follow the same kind of setup that we did before, what they have in common is 2r plus 1. What goes in my parentheses is what I get when I divide by 2r plus 1. So if I take this first term, again, there really are only 2 terms here, and I divide out the 2r plus 1, what's left? X. And then from the second one, y. So we're actually going to stop there for today, and we'll pick up with these. So let me take this part off your homework. But just keep in mind that you don't always have to have a monomial greatest common factor. Hang on. Yeah, I'm going to take off